1 here, which says let A and B be two n cross n matrices such that A plus B is equal to AB. Then the four options given are AB is equal to BA, AB is equal to identity matrix, A is equal to identity matrix, or B is equal to identity matrix, or none of these. Okay, so how should we go about solving this problem?
Okay, the basic equation given to us was A plus B equal to AB.
Right.
Now what we do is AB minus A minus B equal to 0.
Right.
Because in the options we have an IN, I add an IN on both sides. Like I'm going to factorize the equation.
Okay. And this whole adding the IN thing, I mean, how would it strike to somebody that you should go
See,
about
in the
adding
options you have a equal to IN or B equal to IN or AB equal to IN.
Right.
You have an option like it shows us that we require an IN
in terms of IN.
in terms of IN.
Okay.
So I add an IN on both
Okay.
sides. Now I am going to factorize this equation. Now it becomes plus AB equal to IN.
Okay.
Okay.
And since B into any identity matrix is equal to B itself, so it won't matter.
Yeah. So IN into IN minus B minus A into IN minus B
Right.
equal to IN.
Okay.
So it becomes IN minus A into IN minus B is equal to IN.
Okay.
Now since this is an identity matrix which we are getting after multiplication, what does this mean?
That might be those two matrices are the
Yeah, they
inverse
are
of
the
each other.
inverses of each other. That means AB equal to BA. Otherwise you can also infer that A into A inverse equal to A inverse into A is equal to I.
Okay. Okay, so you're saying that if there are two matrices whose product is equal to identity matrix, then those two matrices are the
Inverses of each other. They might be the inverses of each other.
And you can multiply them in any order,
Any
it
order.
wouldn't matter.
Yeah.
Alright.
So what I do is I write it in the inverse order. IN minus B into IN minus A equal to IN.
Okay.
And now I multiply it again. What does it become? IN minus A minus B plus BA equal to IN. But this equation and this equation, they were supposed to be the same equations.
Right.
Because we have just manipulated the same
Exactly.
equation. So that means AB equal to BA.
Since IN, A and B, these three terms will get cancelled. Okay.
That's it.
Okay, so that's our answer.
Yeah.
Alright. So what we've seen in this question is that you are given a relation and you need to determine something based on that relation. Now, इसमें एक पते की बात नोट करने की ये है कि हमें क्वेश्चन में IN के टर्म्स में पूछ रखा था, तो उससे हमें स्ट्राइक होना चाहिए कि हम IN ऐड कर सकते हैं दोनों साइड, और फिर हमने फैक्टराइज किया है हमारे इक्वेशन को. और एक और चीज़ आप देख सकते हैं कि ए बी हमें ऑलरेडी दिया हुआ था और क्वेश्चन में बी ए के टर्म्स में भी पूछ रखा है कुछ. तो ए बी से हम बी ए कैसे लेके आएंगे, वो हमें दिख रहा था कि हमारा एक ऐसा बन रहा था कि सम मैट्रिक्स इनटू सम अदर मैट्रिक्स इज इक्वल टू आइडेंटिटी, व्हिच मींस दोस टू मैट्रिसेस आर द इनवर्स ऑफ ईच अदर एंड यू कैन मल्टीप्लाई देम इन एनी ऑर्डर, जिससे कि हमारा फाइनल आंसर ए आता है. ऑलराइट, सो दैट वाज क्वेश्चन नंबर 1. Alright, so we have question 2 here, which says the inverse of a symmetric matrix, if it exists, is, the options are a symmetric matrix, a skew symmetric matrix, a diagonal matrix, or none of these. Alright, so what should we do in this question?
Let's start with a matrix which is a symmetrical one. So let A be a symmetric matrix.
Right, A is given that it's a symmetric matrix.
So let A be the symmetric matrix we are taking. Then because it is a symmetric matrix, A equal to A transpose, right?
Right, that is a property of a symmetric matrix. Okay.
And we know that A into A inverse equal to A inverse into A.
That is always true for any matrix.
Yeah, into I is equal to IN.
Okay.
Now what we do next is A dot A inverse. I'm taking the transpose of this.
Okay.
So what does that become? Transpose. right?
Taking transpose both
On
sides.
both sides, that is I inverse in ka transpose
Okay.
on both sides. But the transpose of in is in again,
Okay.
right? And here we know that A dot B transpose becomes B transpose dot A transpose.
Okay.
This is the reversal law,
Okay.
right? We are going to apply this law here.
Okay. So this is something which we already know. Okay. Right. So we are applying this law here.
Yeah. So what does that become now? A inverse transpose into A transpose equal to A transpose dot A inverse transpose.
Okay.
Right? Since we know that A equal to A inverse is a symmetric matrix, we will replace this again. So this becomes A equal to A inverse equal to A inverse. So this now here A into A inverse equal to I, right? When we have A into A inverse transpose is also equal to I. That means A inverse equal to A inverse transpose. That's what this is. But easily into this is the problem that we have because we inverse of it. So A into A equal to I, and then that's the same thing that we are using it here. A inverse equal to A inverse or transpose. So that means that A inverse is a symmetric matrix. So that's a pretty easy question. But we have to look at a lot of questions at this time. Okay. The basic idea that this question was that matrix was given that it's symmetric and we have to find the relation of its inverse matrix. Now, when you know that a matrix is symmetric, you know that A is equal to A transpose. How do you go about thinking about its inverse? Now, the natural idea that should come to your mind is that A into A inverse is equal to A inverse in B is equal to 1. That is the standard idea that should take this related to B in terms of inverse. And since we already know the property of symmetry, so we just take the transpose and simplify it. But I believe we know that if a matrix is symmetric, then its inverse is also symmetric. Alright, let's get next question.
Alright, so we have question 3 here which says the system of equations a alpha plus b into x plus ay plus bz is equal to 0, b alpha plus c into x plus by plus cz is equal to 0, and a alpha plus b into y plus b into alpha plus c into z is equal to 0 has a non-trivial solution if, okay, the options are a, b, c are in AP, a, b, c are in HP, a, b, c are in GP, or alpha is the root of the equation ax square plus 2bx plus c is equal to 0. Okay, the system of equations given looks pretty lengthy. So how should we solve this problem?
Okay. The basic thing is here they have asked if the solution has a if the equation, that is system of equations, has a non-trivial solution.
Okay.
Right. Suppose we had a system of equations and that had a trivial solution. That would mean that the determinant of the coefficients of the system of equations would not have to be 0. Right.
Right.
But now this has to be a non-trivial solution. That means the determinant should have been 0.
So basically you're saying that 0 is anyway a solution of the given equation, and if we want any other solution apart from 0, then we want infinite solutions, in which case the determinant should be 0.
0.
Okay.
So let us first write down the matrix. The matrix would be A alpha plus B, A, B, B alpha plus C, B, C, A alpha plus B. I'm sorry.
Yeah. Since the coefficient of
Yeah.
x is 0,
X is 0.
so that is 0.
A alpha plus B, and then B alpha plus BC.
Okay.
This determinant has to be 0.
Right. That is our determinant of A, which is 0.
So we now apply the rules of determinants.
Okay.
What we do is we multiply this matrix by alpha
Okay.
and add this matrix, this row, this column to this column,
Okay.
and then subtract it.
Okay.
Got it?
Yeah.
So A alpha plus B, A into alpha, B into alpha, A into alpha square plus B.
So we are multiplying the column 2 by alpha. Okay.
Yeah. B, C, B alpha plus BC.
And how would one get the idea of multiplying column 2 by alpha?
In the column 1 we have a multiplication of alpha of column 2
Right.
plus the addition of column 3.
Okay.
So that is how we get
So
the
that
idea.
is how we get the terms in
Yeah.
column 1.
Yeah.
Okay.
So basically we do this
Okay.
and then we subtract column 2 and column 3 from column 1.
Yeah, since we have generated the term
Yeah.
in column 1, so we can subtract and get zeros.
Yeah, so this becomes a 0 and then this
Okay.
becomes a 0. And here we get A alpha square plus B. This is a negative.
Yeah, since we are subtracting column 2
Yep.
from column
Yep.
2 plus column 3 from column 1.
Yeah,
Okay.
right? And here this remains the same.
Okay.
Okay,
All right.
now for this determinant to be 0, what should be 0? This element into the cofactor of this element, which would be A alpha into C minus B alpha into B.
Okay, so
Right.
you're saying that you're expanding along column 1
Yep.
and the first two entries are 0, so only
Yep.
the third entry is left.
Yep.
Okay.
So this becomes minus of A alpha square plus 2B alpha plus BC into AC minus B square
Into alpha
into alpha
is
equal
equal
to
to
0.
0. Okay.
That would mean AC is equal to B square or A alpha square plus 2B alpha plus BC should be 0.
Okay. So how do we relate the options given from these two equations?
So if AC equal to B square, this would mean that they are in geometric progression, right?
Okay.
A, B and C are in GP.
Okay.
And if A alpha square plus 2B alpha plus BC equal to 0, that means alpha is a root of this equation.
Yeah,
Right.
the equation in terms of x could be ax square plus 2bx plus bc is equal to 0. Alpha is the root of that equation. Alright, so what we've seen in this question is a given system of equations was given and certain conditions were given that it should have a non-trivial solution. Now we know from elementary system of solutions that since 0 was already a solution, so we wanted other solutions apart from 0, so the determinant should be equal to 0. Now simplifying the determinant was pretty easy because we could have seen that how can we generate more zeros, and then expanding the determinant we got two relations which are directly correlating with the options given. Alright, so that was question number 2. Alright, so we have question 4 here, which says suppose X is a given matrix, 2 by 2 matrix A, B, C, D, satisfies the given equation x square minus 4x plus 3i is equal to 0. Then two statements are given. Statement 1, if A plus D is not equal to 4, then there are just two such matrices. Statement 2 says there are infinite number of matrices X satisfying x square minus 4x plus 3i is equal to 0. Okay, so how should we start solving this question?
Well, the basic idea is they have given you x square minus 4x plus 3i equal to 0.
Right.
So what you're going to do, you're just going to substitute x in that equation
Okay.
and equate the elements to 0.
Okay.
But since that is going to be a lengthy procedure, I'm just going to factorize the equation.
Okay.
So x square minus 4x plus 3i equal to 0.
Okay.
This becomes x minus 3, okay, x square minus 3x minus x plus 3i equal to 0.
Right.
That becomes x minus 3 into x minus I into x minus 3 equal to 0. Okay?
Okay.
So that becomes x minus I into x minus 3 equal to 0. That means 3i equal to 0. Okay?
Right.
Well, you just can't subtract a scalar from a matrix. So it just it has to be
Yeah.
another matrix.
Yeah.
So x minus 3i into x minus x minus 3i. Okay? So this now becomes x minus I into x minus 3i equal to 0. Now I'm just going to substitute x in this equation, which becomes a, b, c, d minus
Identity
this is
matrix.
an identity matrix, well, that is 1 0 0 1
Right.
into ABCD minus 3 0 0 3. I've
Okay.
just multiplied the scalar with the identity matrix. Okay, so now this becomes A minus 1, B minus 0 is a B, C minus 0 is a C, and D minus 1
Okay.
into A minus 3, again a B minus 0 is a B, C minus 0 is a C, D minus 3 is equal to a 0. That is a
Okay.
0 matrix. It's just not a 0, okay?
Yeah, that means null matrix.
Yep. And now when I multiply these two, what I get there? A minus 1 into A minus 3. I'm multiplying this row with this column
Okay.
plus BC. Okay, and now this row with this column. A minus 1 into B plus B into D minus 3.
Okay.
And now here, this row with this column.
Right.
C into A minus 3 plus D minus 1 into C.
Okay.
And now this row with this column.
Right.
That's a BC plus D minus 1 into D minus 3. Right?
So
now
that is
this
your
matrix
null matrix.
has to be equated to a null matrix. That means all the elements of this matrix are equal to 0.
Right.
So that gives us,
So that'll give us 4 equations.
yep,
Okay. Let's see what those 4 equations are.
yeah, A minus 1 into A minus 3 plus BC equal to 0.
Okay.
And I'm writing this element below that, plus BC equal to 0. They are looking kind of similar, that's
Yeah.
why. And
A
here I'm
and
writing
D
these two
are
equations, A minus
replaced.
1 into B plus B into D minus 3. Well, that becomes B into A plus D minus 4 equal to 0, right?
Okay.
And this element I'm writing down here, C into A minus 3 plus D minus 1 into C, which becomes C into A plus D minus 4 equal to 0.
Right.
Right? Now from these two equations, what do you get? Well, let's have a look at the question.
Right.
Well, we were given that in statement 1, if A plus D not equal to 4, then there are just two such matrices.
Okay.
Well, now let's just check that.
Okay, let's
well,
take the case of A
yep.
plus D not being equal to 4.
Yeah, here
Okay.
A plus D is not equal to 4.
Okay.
So what could be the possible solution? B has to be 0.
Exactly.
That means B has to be 0,
Right.
and C also
Similarly,
has to be
C
0.
also has to be 0.
Right?
So these are fixed.
Yeah, these are fixed.
Right.
And now from these two set of equations, what do we get? A plus D is not equal to 4, right?
Right.
And BC
and
is
BC
equal to
is
0.
anyway 0.
So A minus 1 into A minus 3 equal to 0.
Right.
So that gives us A has to be 1 or 3.
Right.
Similarly, D minus 1 into D minus 3 equal to 0.
Right.
That gives us D equal to 1 or 3.
Right.
Now
we
there
could
would-
have
yeah,
this would mean, could we have 4 solutions
Yep.
possible?
like AD, it could be 1 1,
Okay.
1 3, 3 1, or 3 3.
Right.
But we were given that we were doing it under the assumption that A plus D is not equal to 4.
Right.
That means A plus D can't be 4, A plus D can't be 4.
All right. So 4 possibilities were there,
Yep.
but since we assume that A plus D is not equal to
Yeah.
4, 2 possibilities are eliminated.
Yeah. And those two
Okay.
are A equal to D equal to 1 is
Right.
one case when B and C are 0.
Right.
And the other case will be A equal to D equal to 3 when B equal to C equal to 0. So what
Okay.
are the two matrices? A is 1, B is 0, C is 0, and D is 1.
Right.
Or A is 3, B is 0, C is 0, and D is 3.
Okay. So
So
only
these are
these
the
2
two
possible
matrices.
matrices are possible.
So
Okay.
the statement 1, this one, if A plus D is not equal to 4, then there are just two matrices. This is true.
Okay. So this is right.
Yep, this is right.
Okay.
And now there are infinite number of matrices X satisfying x square minus 4x plus 3i equal to 0. Here we are
Okay.
not given the condition that A plus D is not equal to 4. That
Okay.
means A plus D can be a 4.
Right. Since
So-
any condition is not given, we can
Yeah.
assume it to be 4 also.
Yeah. If A plus D is a 4, then what do these two equations become?
If A plus D is equal to 4, then those two equations are anyway 0 on the LHS side. So B
Mhm.
and C could be any value.
Yeah, B and C, they could be any value.
Right.
And if B and C are any value, we just have infinite number of solutions for that.
Okay.
So the statement 2 is also true.
Okay. What about the first set of equations? If
Yeah.
a plus d is equal to 4 and b and c are any value, then those
Okay.
two equations should also be satisfied, right? The first set of two equations which we have here,
Which
those these set of equations that we have,
Okay.
we can say that if a plus d is equal to 4
Hmm.
and supposing that a is equal to 1
Yeah.
and d is equal to 1 or d is
Yeah.
equal to 3,
Yeah.
then a plus d will be equal to 4
Hmm.
and this term, your a minus 1 into
Mhm.
a minus 3
Yeah.
and your
Hmm.
d minus 1
D minus
into
D
d
minus
minus
3.
3 will be 0.
Yeah.
So the only condition left will be bc is equal to 0.
Yeah.
In that case we can assume, let's say b is equal to 0, so c could be any value.
Yeah.
Right, that is why we
Yeah,
are getting
have
infinite solutions.
number of solutions. When b is 0, we have infinite number of solutions for c.
Okay. So what we've seen in this question is that a given quadratic equation was given in terms of a matrix x and certain statements were given. What we did was, instead of directly opening up the quadratic equation,
Yeah.
we first factorized it and then we opened up.
Yeah.
Now we had to equate it to the null matrix, so
Yeah.
we got 4 equations.
Hmm.
And in the question already such statements are given, whether a plus d
Yeah.
is equal to 4 or not equal to 4.
or not equal
So
to
when you put those equations, when you put those assumptions in your equation,
Hmm.
they'll get simplified and you can see whether how many possible solutions are possible.
Yeah.
All right, so that was question number 4.